Today we're talking about learning goal number 9, rational numbers, fraction and decimal changes. So rational numbers are numbers that can be written as fractions. So anything that can be written as a fraction. For example, -5 is an integer, but it can be written as a fraction as -5/1. Those are the same thing. Another example would be 2 and 2/7. It's a mixed number, but it can still be written as a fraction. 7 times 2, 14, plus 2 on top, 16/7. These are examples of rational numbers. Now, rational numbers, again, any number that can be written as a fraction. It could be an integer or a whole number, a positive number, or it could be a mixed number of any kind, an improper fraction, or a regular fraction. Any number that can be written as a fraction. So the goal today is to work with rational numbers. And the first type of problem we're going to look at is writing a fraction as a decimal. So let me give you a fraction here. Okay, example number 1, 3/4. We want to write 3/4 as a decimal. So to do so, we're going to look at it as division. 3 is being divided by 4. So 4 on the outside, 3 goes on the inside. I'm going to add more zeros just in case we need them. If we end up with a remainder of 0, we can stop. If I look, 4 goes into 3 0 times. 4 goes into 30, 7 times. 7 times 4 is 28. I subtract those two, I bring down a 2, bring down another 0. 4 goes into 20 5 times. 4 times 5 is 20. So when I subtract those two and I end up with a remainder of 0, I would just continually bring down more and more zeros. So that's where this problem ends. And 3/4 is the same thing as 0.75. That is writing a fraction as a decimal. These are rational numbers because it can be represented as a fraction. Okay, let's move over to example number 2. 3 and 1/11. Okay, 3 and 1/11. Before we do this, let's convert it to an improper fraction. So 11 times 3 is 33. 11 times 3 is 33. Add that to the top, you get 34/11. So 34 is being divided by 11, so let's go ahead and do that. We're going to take 11 on the outside. We're going to put 34 on the inside. Add our zeros there to get us started. If I ever need to add more zeros, I can. Okay, and I go ahead and I go, okay, how many times does 11 go into 34? Well, 3 times. 11 times 3 is 33. All right, subtract. I get 1, bring down a 0. How many times does 11 go into 10? It doesn't, 0 times. All right, let's continue. Bring down another 0 then. How many times does 11 go into 100? 9. 11 times 9 is 99. Go ahead and subtract those two. 100 minus 99 is 1. Okay, so I brought down this 0 and I brought down another 0. Okay, bring down another 0, we get 10. 11 does not go into 10, so we'll put a 0 there. All right, let's bring down another one. All right, 11, it goes into 100. Well, we already know this 9 times, right? So you see how this 100 continues to show up? That's going to create what we call a repeating decimal. So we know 11 is going to go into that 9 times, and you get 99. And then when you subtract them again, you're going to get that 1. And that 1 continues to show up and show up and show up, and that trend is going to continue on. So what we're going to do is we're going to stop right there, and you can see that this 0.9 is going to repeat. So as soon as I start seeing that repeat, I know that that's actually going to be my answer. It's 3.09, and what I do is I put this little bar above the 0.9, and that's called bar notation because that's going to continue to repeat and repeat and repeat. So with that being said, we've seen one where the decimal stops, but we've also seen a repeating decimal. So let's add a little bit of vocab right here. Okay, a terminating decimal is a decimal that ends. For example, 0.75. That stopped. It didn't repeat. A repeating decimal is a decimal that never ends, and we use bar notation for. So for example, we did 3.09, and the 0.9 continually repeated. 1/3 is a common fraction we see a lot, and 1 divided by 3 is 0.3 repeating. And the 3 repeats forever. So we use a bar over the 3. So difference between a terminating decimal and a repeating decimal, going from fractions to decimals. Now, Let's go in reverse. Example number 3, we're gonna write a decimal as a fraction. So let's start with, we'll say 0.12. So we wanna take 0.12 as a decimal and write that as a fraction. So what we need to do is we need to take 0.12, we need to move it so it's a whole number. So if I move the decimal twice, I would get 12. Well, I'm gonna put that over top of 1 and then however many zeros is the number of times I moved the decimal. So since I moved it twice, it's gonna be over 100. If I only moved it once, say it was 0.8, like say it was 0.8 and I only moved it once, I would put it over 10. But since it was 0.12 and I moved it twice, I'm gonna put it over 100. And then all I have to do is I have to simplify this fraction. So 12 over 100. 12 and 100 are both divisible by 2. So 2 goes into 12 6 times, 2 goes into 100 50 times. And then I keep checking. 6 and 50, again, are both divisible by 2. 2 goes into 6 3 times, 2 goes into 50 25 times. Awesome, great. 3 over 25, 3 does not go into 25. There's your answer. 0.12 is the same thing as 3/25. Okay, that is when you have a terminating decimal, a decimal that stops. But if you have a repeating decimal, for example, 0.27, okay? 0.27, this is gonna be a little bit of a different approach here. First of all, we say that n equals 0.27, repeating. I'll just show it like that. And what I have to do now is, since there are 2 decimals that are repeating, again, there are 2 decimals repeating. What I'm gonna do, like over here when there were 2 decimals repeating, I put it over 100. Here I set it equal to n, and what I do is I multiply both sides by 100. So 100n equals, and then over here, if I take 100 times this, it's gonna move the decimal 2 places to the right. So I get 27.2727, and it repeats forever. Okay, so now, hopefully you followed that part. The next part's gonna be a little bit confusing. What I have to do is, I have to now try to get rid of the repeating portion. So the repeating portion was n, it was equal to 0.27 repeating. What I need to do is subtract n from both sides. So if I subtract n from 100n, I get 99n. Okay, follow me here. And then if I go over here and I take away n from this side, well, n is equal to 0.272727. So I'm taking off this portion of the number, and I get 27. I know, tough to follow. But from here, now, n is being multiplied by 99. I'm going to divide both sides by 99. And n is equal to 27 over 99. So that's something to start with. That's something to work with. What I'm going to do from here is I'm going to simplify that. 27 and 99 are both divisible by 3. So 3 goes into 27 9 times, and 3 goes into 99 33 times. Okay, 9 and 33 are both divisible by 3. 3 goes into 9 3 times. 3 goes into 33 11 times. Very good. So 3 over 11, that's simplified. That's equal to 0.27 repeating. If you were to type 3 divided by 11, or if you do a long division, you would get 0.27 repeating. A little bit more difficult. We need to work with that a lot. This one's a little bit easier on you. But still, both of these you need to know how to change a terminating decimal to a fraction and a repeating decimal to a fraction. Now you need to take some time and practice these few problems.